Now, let's think for just a moment. When an octahedral molecule has elongation of the coordinate covalent bonds along the equatorial positions, what orbitals are affected? And what does the Jahn-Teller, or what does the crystal field splitting diagram look like? So, just to mention, this here that I'm circling, this part right here, is the crystal field splitting diagram. Nothing else is necessary. You need to know where the barycenter is. But this part right here is the most important part to you. So which orbitals are affected here? Anything with an X and Y component are going to be interacted with less because the ligands are moving away. So you would expect maybe that the dx squared minus y squared will go down in energy, and you would also expect the dxy to go down in energy. Whereas the bonds along the z-axis tighten up, so you expect the energy for the dz squared to increase and the dxz to increase and dyz to increase. And that's what it looks like. So you should be able to rationalize, just based upon a simple diagram like that, what the crystal field splitting looks like for an octahedron, even if I distort it. Now let's derive square planar crystal field splitting patterns. So remember, when we looked at the Jahn-Teller theory, originally we elongated the bonds along the z-axis and moved those ligands far out, leading to an increase in energy of the dz squared, or dx squared minus y squared, and an increase in energy of the dxy. Now we're just going to pull these so that they're moved infinitely away, leaving only 4 ligands along the x and y axes. So what orbitals are affected directly by removing these 2 ligands? Anything with a z component, such as the dz squared or the dxz and dyz. All 3 of those should be affected. So you should expect that the energy for the dz squared should go down, and the energy for the dx squared, or dxz and yz should also decrease. And there it is. And as a matter of fact, what happens is that by removing those ligands, remember, this is the crystal field splitting diagram right here, and it's derived from an octahedral crystal field splitting diagram. What you see is that the dz squared is stabilized so much by removing those 2 ligands, because that's the one that the ligands interact with most, that its energy actually drops below the dx squared or dxy. You need to memorize this pattern if you can't rationalize how I got this.